Welcome to the task 3 video to help you guys get ready for project number 3. Go ahead and make sure you guys have an empty spreadsheet open like so. If you guys don't know how to do so, just go to sheets.google.com and go ahead and click blank sheet to get you guys started on a blank slate. Couple of logistics before we actually start dealing with the mechanics of the project, or really task 3. If you want to be able to watch this video while also doing it, which again, highly recommend, just so you can kind of go back and forth very quickly, pause the video when you need to. I would say, suppose our video is in this tab right here, in my new tab, and in my spreadsheet is right here. One easy way to do it instead of clicking every single time is if you do Control Tab, it goes into the next tab to the right. So I started on this tab here on the left, Control Tab goes to the tab on the right. If I had another tab here, let's go back to the beginning, Control Tab just kind of cycles through each of the tabs and it goes back to the beginning. Now if you want to go backwards, like going the other way, Control Shift Tab goes the other way around. So notice that I'm going to the left now, and it cycles back and goes to the left. Another way to do it as well is you can split screen, so drag your video out to the right side of the screen, have your spreadsheet on the left side of the screen, so it looks something kind of like this. Mine doesn't do it well for some reason, so I'm just going to do it like that. Okay. All right, and then the last thing to do is if I maximize each of these tabs separately, you probably see me already do it. If you do Alt Tab, they're in separate windows, right? So this is in one window. If I drag this out, you see here's the other window for the video, right? If I do Alt Tab, I can go between each of the windows very quickly. Makes it super nice. All right, let's close this one. Let's go back here. So to get us started here, again, remember, I'm referencing task number 3, which is this right here. Your instructions might look a little bit different here, but it should be roughly the same. And we're basically using this compound interest formula to help us out here. So back here, let's do a couple of logistics of setting things up. Let's call this task3 _ your last name. My name is Mr. Park, so we're going to go from there. And then down at the bottom here, you see there's also a name for the sheet itself, and this is really confusing and it's kind of annoying, but it is what it is. The Google Sheet file name is sort of like the general file itself, but within a Google Sheet file, you can have multiple spreadsheets. So you can see I can add a spreadsheet, I can add a spreadsheet. Makes it super convenient to include a bunch of them together, which is what we're doing for this project. But it is a little weird with the naming convention, but it is what it is. So here we're going to double click, or you can right click. I'm going to double click here to change the name, and I'm just going to change this to task 3 because that's what we're doing right now. Alrighty, let's get started with the content. So in order to get started, what we're trying to do is we're trying to visualize and make Google Sheet calculate all the numbers for us to understand this formula a little bit better. So a couple things I'm going to start off with. I'll explain once we get to that part when we're actually dealing with it. So I'm going to say compounding number, actually let's say compound number. We'll say the initial amount, say final amount, and then we'll say interest accrued. This is a totally optional column. You don't really need this for your project, but it is nice to kind of visualize what's going on as we're doing this. We also need the principal. We need the annual percentage rate. And then we will also need the number of times compounded per year. I'm putting this in all caps because of how important it is. If I go back right here, these bullet points here are kind of explaining what we need. I just put it right here. Now, formatting is absolute garbage. You're probably like, Mr. Bright, why did you put all of these in column F and all these here? I'm creating sort of a set of fixed values here that are important, and then this will basically be the table of values. So let's go ahead and bold this. Control B will bold it, or if you just click bold here, works as well. Let's bold those. And then what I'm going to do is I'm going to center all this. So I'm going to take this, all the columns, not just the cells here. I want to take all of column A, B, C, and D, and I want to center it. I want to take this column here in F, go and center that. And then I'm going to go ahead and double click this edge right here between F and D, or F and G, and it'll automatically move things for us. Actually, come to think of it, I don't really like it centered. I kind of like it like that. Line to the left, and then I notice here for column D, that's a little off, so we're good to go. All right, perfect, lovely. I'm gonna make a little box around this just to be like, here are my fixed values. These are kind of the values I'm gonna throw in, and then that might change what happens over. Kind of like it's like your independent variables and then your dependent variables. So for principal, let's keep it simple. Let's do $10,000, make it easy. And you guys wish you had 10,000. No, all of us did, but let's just make up a scenario here. Now, the issue is this is a number, not a money or currency value. So luckily for us, there's the easy formatting value. We can change it to a currency very quickly, and it also adds the decimal places. Lucky for us, we can also just change it. You can increase, decrease as needed if you just want the whole dollar amount. If you want every penny, that's fine too. APR, the annual percentage rate, we're going to keep it simple. We'll say 0.05, or in other words, 5%, right? Keep in mind, just the decimal to the percentage is a little bit off. You got to change the numbers around a little bit. And here is the super important part in relation to the APR, the annual percentage rate. If I say 1, what that means is every single year, I'm going to take this 5% interest rate and then apply it to my $10,000, right? So after the first year, it's going to be 5% of 10,000, which is 500. So you would have 10,500 at the end of the first year. At the end of the second year, you take the 10,500 that you just had and you apply another 5% interest rate on it. Now here's the catch. If you compound it twice a year, does that mean you're taking 5% and doing it twice a year? No. If you did 5% twice a year, that's actually really 10% for the whole year. What you want to do is you distribute the 5% across those two compounding periods. Or in other words, you take the 5% and distribute it across the 6 months. Because remember, twice a year really just means 6 months, right? So you take the 5%, evenly distribute it. Well, what's 5% divided by 2? Oh, that's just 0.025. And so this, if you want to, could just be like the actual interest rate per compounding period, per compounding number. What do you want to call it, right? So it's just going to be that. Now, if it was 12, right, that means it's the 5% distributed equally across the 12 months, which would just be the 5% divided by 12, which gives you some pretty small number. So if you say equals, let's say, 0.05, I'm using a formula here. I'll explain this later as well. Divided by 12, it gives us that tiny percentage rate. You're doing this every single month, not this every month. Man, if you had 5% every month, whew, that's a lot of money. Anyways, I am digressing here. Let's keep this as 1 for now, and then we'll go over later once we're done with all this what changing this number does. But let's just keep all this fixed. 10,000 for principal, the 0.05 for the interest rate, R, number of times compounded, 1. So when I look here, this is the compound number. I'm going to say 1, I'm going to say 2, I'm going to say 3. I can keep going. But really, what does a compound number really mean? If I'm only compounding once a year, that just really means the first year. This means the second year. This means the third year. If I change this to 12, for example, this means I'm compounding 12 times per year. The first compounding interval, that happens, month 1, month 2. I should say the end of month 1, the end of month 2, the end of month 3. If I say 52, right, that's every week. You can now see the pattern that happens when you change this number, what happens to these guys right here. Now, just to clarify, later for part 2, you're going to be doing an inverse idea. You're going to think that, in part 1, or in task 3, what we're really doing here is we're changing the number of compounding statements, right, or the number of times we compound. And while that might be true, what we're really trying to do is see what happens during each compounding statement. All I really end up caring is the yearly stuff. So if I'm saying one time per year, this really just means year 1. This really just means year 2. This really just means year 3. If I change this to 2 to biannual, that means this is year 1, right? Compound 4 is year 2. Compound 6 is year 3, so on and so forth. We want to really look at the time in relative to the years, but we're doing this right now just so we can see, hey, if I break it up little by little, what is actually going on? Now let's change it back to 1 over here. That's year 1, year 2, year 3. You might think, I can just type in 5, 6, 7 manually. It's like, no. Let Google Sheets do the work for you. Here's how you go about it. You just need the first 2 numbers here. Sheets will figure out, hey, he's trying to do a pattern, or she's trying to do a pattern. So if I click this bottom right box here, you'll notice that, it will continue the pattern until where you stop it at. So I just need year 30. So I need to go to year cell 31. Bam. There we go. We got 30 years. We're good to go. Now remember, this is 30 years because we're compounding only once a year. If it was twice a year, you would have to change the number respectively, because twice a year times 30, you get the deal. Let's get started with the initial amount at the end, or I guess at the beginning of year 1, you could say. So at the beginning of year 1, we said, hey, this is going to be equal to 10,000. Now you can just type 10,000, or you'd say, hey, let me refer to this cell. These are my numbers that don't change, so why don't I just go ahead and do that? And the reason why we want to do it like this is because it's kind of like a programming principle where you say that this cell here, the value here, depends on this value over here. So watch, if I change this to $1, the initial amount here changes as well. It's nice because, yes, we want to keep these numbers fixed, but should we want to change them, we can easily change this without changing everything else inside of here. And this is where self-referencing is super useful for us, okay? So the final amount means at the end of the compounding statement, so remember, we're compounding once per year, we're applying that 5% interest rate once a year, which makes sense, annual percentage rate once a year. We're going to add 5% on to this value. Well, how do I find 5% of this value? We're going to say equals, and this is where we include a formula, right? We're going to say equals the initial amount right here, 10,000, multiply, let's go back here real quick. This is, again, the initial amount, or the initial amount for that year, times the interest rate. So this is the interest rate. We're going to say, hey, it's 100% of the principal plus what we say the compounding. The interest rate, the APR, divided by the number of times we compounded. The APR, which is 0.05, divided by the number of times we compounded. So if I say, let's make sure I get this right. It's going to be 1 plus, I'm going to click this one right here. I'm going to say divide by this one right here. Close the parentheses. And you'll notice that this pop-up comes up. It gives you a preview of what your answer would be. Let's check it logistically before we talk about the actual values or the cells that we kind of refer to inside. This makes sense, right? 5% of 10,000 is $500. At the end of the first compounding period, we said, hey, add 500 bucks. Here we go. Let's look at the formula. It takes the initial amount of that compounding period. It says, hey, the interest rate is equal to the APR divided by the number of times we compounded. 0.05 divided by 1 is indeed 0.05. Were I to change this number to 2, watch what happens in cell C2, the final amount. This makes sense. It's not 5% every 6 months, because now each compounding period is 6 months instead of 12 months or a year. It's now going to imply 2.5% because it's dividing the 5 by 2. If I said 12, it's that crazy little number, and this is what happens here. This is great because we can change these numbers here when we need to, and it will update these automatically. Now, let's touch base here on these formulas up top. We know that this makes sense because this first number represents the initial amount of that compounding statement. It depends on the initial amount of that year, of that month, whatever the time frame is. These values here, though, G2 and G3, these are fixed, right? It will always be whatever the value is here. It'll always be the value of whatever is here. So if we try doing that pattern thing where we take this bottom right-hand corner and try to drag it down, you'll see something happens in the second year. So this won't work now because I need the initial amount here. So let's think at the second year or the second compounding interval. Isn't the initial amount here depending on the final amount in the previous year? So I could say equals this guy right here. Now let's try to do this. Instead of copying and pasting this formula, because that's going to take too long, let's just drag this down. It should copy and paste the formula, and it'll say error. Now let's go back here. We said this made sense because of the concepts that we had up here, right? These all make sense. If I go down one, notice all of these numbers, all of these cells changed by 1. It's kind of like when we went over here, we dragged this down, it changed everything by 1, so to speak. Oh, whoops. Over here, the same thing happened. Look at B2, G2, G3. Notice what happens when I go down. B3, G3, G4. If I double click this now, and I see it's now saying that this purple spot is the APR, and this cyan spot is the number of times compounded. We don't want this purple and cyan part to change. Again, your colors might be different, but just for my video's sake, you can see the colors here. We want these values to be fixed, but the B3 is totally fine. B3 is basically the initial amount of that compounding statement. We want that. So what we need to do is we need to erase this. We got to go back up here and fix some ideas. B2 is what we're using as a relative cell referencing. We're relating it to the cell to the left. Here, we get down to this one. It's this cell to the right or left. You go to this cell, to me, this cell to the left. From this cell, oh, the initial amount would be this cell to the left. However, these values here, the APR and the number of times compounded, those must be fixed. This is what we call absolute cell referencing. So to do that, we just put $signs in front. That's the Google Sheets way of going about saying, hey, these are cells that do not change no matter how I move this formula around. Hit enter. Nothing changed the value. It just changed where I'm referring to. If I now drag this down now, we notice that we get an actual number. If I click this cell here, double click it, B3 is the initial amount for that compounding year, or basically at year 2. We then apply the interest rate, right? The 1.05, or the 5% interest rate, divided by the number of times that year, so 1. So 5% interest rate on top of that $10,500. We then get exactly $11,025. And that is exactly correct. Put it in your calculator, see what happens. That's exactly what happens. At the end of year 2, we get this amount. So now we have a formula that works here. We have a formula that works here because it just depends on the final amount of the previous year. I can now just click and drag this all the way down. Now it seems like nothing happened, but if we take a look, each cell is, hey, C5 is here. It's the final amount of the previous time. C6, or B6, is the final amount of the previous one in year 5. So then I can do the same thing here, and this is where the magic kind of all happens simultaneously. Don't get too excited. All right, here we go. All that matters is if your formula matches up and it makes sense with what you're trying to do. You can easily see every year, again, technically it's every compounding statement, but really it just ends up being every year. Every year we're adding 5% to the previous amount of that year. And we just notice that it keeps going and going and going. So we start with 10K, at a 5% interest rate compounding once per year, you end up with 43K at the end of 30 years. That's not too bad. 10K to 43K doing absolutely nothing except just leaving money into that retirement account. Not too bad, not too bad. This column is great for you to visualize like how much money actually is growing each year. So like I say is to get the interest accrued, isn't that just the final amount and then compare it to the initial amount? So equal sign the final amount minus the initial amount. And it tells us exactly, hey, just take the final minus the initial, we get the interest accrued. If I just drag this down a little bit, we can see as the years go on, you continue to get more and more interest because the initial amount keeps increasing from the previous times. So this is basically a giant multiplication problem. It's like, well, this number is just 10,000 with the interest rate applied 6 or 7 times. So just apply the interest rate over and over and over and over again, and you get this guy right here. So hopefully that gives you more visual aid, but suppose you need an even more visual aid and top out these numbers because these numbers are just giving you a headache. So the way you can go about that is when you take our input column, and really it should be years, but we're just going to go with compounding numbers now just so you can visualize it, and then we go to the final amount. So I hold control, so let me try again. A, hold control, select column C, and now I can go to insert a chart. So from here, most likely Google Sheets will do the work for you where it just makes the chart a line chart. If that's not the case, let me just move it over here just so we can see it better. If that is not the case, you can go ahead, I'm going to double click this. Let's go to setup. You can click the chart type and just scroll down and just click the chart type that you need. Line chart is fine for what we need right now. That's totally okay. So from this point, we can now say, hey, this is a graph representing, hey, the compounding value of the number. So in this case, it would be really just years. So year 5, you can see the value. Year 10, you can see the value, so on and so forth. And then the final amount is how much you make in that retirement account after a certain amount of time. So what we want to do is we can see, hey, clearly there's a relationship going on here. If I go to my customize section and I go to series, scroll down all the way to the bottom of that section there. If you click trend line, what this will do is it will create a line of best fit, or depending on the options you pick, you can probably guess which one you need. I'm going to say it right now. Which option you pick for the line or curve of best fit. We can then click label and use the equation to show us, hey, this is the line or curve of best fit that explains the function to us in, say, a linear manner, or in other cases, a polynomial manner, or a logarithmic manner, so on and so forth. I'm going to get rid of that. I'm just going to do Control C just to get rid of that. Perfect, we're good. So, super nice way to kind of visualize things as time goes on. We can clearly tell, based on what I put here, it does not seem to be a linear fashion. It's not increasing at a linear rate. It seems to be increasing more and more rapidly as time goes on. So this is kind of all you basically need. If you want to rearrange certain things or just kind of reorganize the way this looks, totally cool with that. I will say your project requires a little bit of extra finesse because this is not necessarily realistic if you're a person who just doesn't like to add money to it. Most people, what they do is they will start with a certain amount. So it could be like $0, it could be $1,000. It doesn't have to be 10,000. But what will happen is you'll slowly add money every single compounding period. So if this was like, year 1, year 2, year 3, which again, not realistic as well. Like if this was more like 12. So this really means month 1, month 2, month 3, month 4, month 5. And you see everything else changed with it, right? This is saying $41.67 at the end of the first month. $41.84 gained at the end of the second month. What this now allows us to do is we're going to say, hey, suppose you contribute a certain amount every month or every week or however many times you compound it. That's going to drastically change the complete outcome. That's what you guys need to figure out for Project 3. That is the sort of the challenge or the essence of the project. This all I gave to you. What now you need to do is figure out how do you add in the contribution as we go from there. Now, another thing to help you guys out with is when you're working on part 2, you're going to have to be dealing with logarithms. So if you want to use logarithms within the task, within the Google Sheet file here, you can Google this, it's pretty straightforward. But if you just type in equal sign and type in log, you notice there's a whole bunch of different formulas that Google Sheets has for you. If you click on the first one here, it'll give you like a hint about, hey, here's what you need. The first number here and the second number here. So it's saying it's the value and it's the base. Or in other words, it's going to be log of the value in terms of the base. So if I said, it's like this is the big number and this is the small number. Really, this is just log base 2 of 8. So in other words, 2 raised to what power equals 8? Oh, the answer is 3, right? I just keep going. Log, and we could say like 16, 2, right? 2 raised to what power equals 16? Oh, the answer is 4. You can even do this with natural log, ln, natural logarithm. And you guys remember, if I put natural logarithm of e, right, log of e, log base e of e ends up being just 1. So I can't just type e though, because it doesn't understand I'm trying to use the natural log here, or sorry, the Euler's number. So you just need to type something pretty close. So it's like 2.718. You can see it gets really close to 1. And that's close enough for us, right? Boom, there you go. You get these numbers here. Super useful, helpful for us when we're doing our part 2 section of project 3. But in essence, that should basically be all you guys need to know to get you guys started. Again, there are some challenging components to it where you need to kind of finesse with some numbers and play with the formulas. But one, I hope this helps you understand, like, oh, Google Sheets and Excel is a pretty fancy, nice tool to have to compute some data for us. And two, hopefully recognizing that as you guys also go into life, the idea of, putting a little bit away at the beginning and just doing a little bit of initial understanding of how the compound interest works might lead you to a nice outcome in the future. Now again, this number is different because again, we changed this to compounding for 12 times per year. So if I really think about it, this 30 is what, like 2.5 years? So you got to keep this going to find out how much it would be after a long time to get to 30 years. But that you can figure out on that part there. And notice the graph changes as well, so it's super nice. But hopefully this helps out with getting you started for task 3, which then leads you to project 3, and you all should be good to go.